Have you ever wondered about the star at the center of our solar system? The Sun, a massive glowing sphere of hot plasma, is the most important source of energy for life on Earth. Without it, our planet would be a frozen wasteland. The Sun is a giant ball of burning gas, primarily composed of hydrogen and helium. Its surface is a seething, boiling mass of energy, constantly churning and erupting. It gives us light and heat, which are essential for life on Earth. The warmth of the Sun nurtures our ecosystems, drives our weather patterns, and provides the energy that sustains all living organisms. But it also releases powerful bursts of energy, known as solar flares and coronal mass ejections. These phenomena can send massive amounts of charged particles hurtling through space. These bursts can affect us here on Earth, disrupting satellite communications, power grids, and even causing beautiful auroras near the poles. To understand the Sun better, NASA launched a special spacecraft. This mission aims to unlock the secrets of our star and help us predict solar activity more accurately. It's called the Parker Solar Probe, named after the pioneering solar astrophysicist Dr. Eugene Parker. This probe is on a daring mission, venturing closer to the Sun than any spacecraft before it. Its goal is to touch the Sun, or at least get as close as possible to its scorching surface. The Parker Solar Probe is not actually flying into the Sun itself. That would be impossible due to the extreme temperatures and intense radiation. The Sun is far too hot, with temperatures reaching millions of degrees in its core and thousands on its surface. Instead, the probe is traveling through the Sun's outer atmosphere, a region known as the corona. This region is called the corona, and it is surprisingly hotter than the Sun's surface itself. By getting closer to the Sun than ever before, the Parker Solar Probe will help us solve some big mysteries, such as why the corona is so much hotter than the surface. Its findings will teach us more about how the Sun works and how it affects our planet, potentially safeguarding our technology and improving our understanding of the universe. The Parker Solar Probe is on a mission of discovery. It has several important objectives. One of its main goals is to study the solar wind. The solar wind is a stream of charged particles that constantly flows from the Sun. These particles travel at incredibly high speeds. When they reach Earth, they can interact with our planet's magnetic field. This interaction can disrupt satellites, communication systems, and even power grids. The probe will help us understand what causes the solar wind and how it accelerates to such high speeds. This knowledge is crucial for predicting space weather events and protecting our technology. Another mystery the Parker Solar Probe aims to solve is the coronal heating problem. The Sun's corona, its outer atmosphere, is much hotter than its surface. Scientists have been puzzled by this for decades. The Parker Solar Probe is named after a brilliant scientist, Dr. Eugene Parker, whose contributions to astrophysics have been nothing short of revolutionary. His work has paved the way for many advancements in our understanding of the cosmos. Dr. Parker was the first person to predict the existence of the solar wind, a concept that was groundbreaking at the time. His theories challenged the conventional wisdom and opened up new avenues of research. His groundbreaking work revolutionized our understanding of the Sun and its influence on the solar system. The solar wind, as he described it, plays a crucial role in shaping the space environment around us. In the 1950s, most scientists believed that space was a vacuum, devoid of any matter. This was a widely accepted notion, and few dared to challenge it. But Dr. Parker's calculations showed that the Sun was constantly releasing a stream of charged particles into space. This was a radical idea that required a deep understanding of both mathematics and physics. He called this stream the solar wind, a term that has since become fundamental in the field of heliophysics. At first, Dr. Parker's theory was met with skepticism. Many scientists found it hard to believe that the Sun could have such a profound impact on space. But in the early 1960s, observations from spacecraft confirmed his predictions. These observations were crucial in validating his theories and changing the scientific community's perspective. The discovery of the solar wind was a major breakthrough in solar physics. It not only validated Dr. Parker's work, but also opened up new research opportunities in space science. NASA decided to name the solar probe after Dr. Parker to honor his remarkable contributions to science. This was a fitting tribute to a man whose work has had a lasting impact on our understanding of the universe. Dr. Parker was present at the probe's launch in 2018, witnessing the beginning of a mission inspired by his own work. It was a moment of great pride and accomplishment for a scientist who had dedicated his life to unraveling the mysteries of the sun. The Parker Solar Probe carries a suite of scientific instruments designed to study the sun up close. These instruments are measuring the properties of the solar wind, including its speed, density, and temperature. By analyzing the data collected by the probe, scientists hope to answer some fundamental questions about the solar wind. What are the mechanisms that drive the solar wind? How does the solar wind accelerate to such high speeds? What role does the sun's magnetic field play in shaping the solar wind? Understanding these processes is essential for predicting space weather events, which can have significant impacts on Earth. The probe is also investigating the sources of high-energy solar particles. These particles, known as solar energetic particles, can pose a radiation hazard to astronauts and spacecraft. Section 5. Engineering Marvel: Withstanding the Sun's Fury. Designing a spacecraft to fly so close to the Sun is, well, a remarkable feat of engineering. The Parker Solar Probe is a testament to human ingenuity and perseverance. Engineers and scientists have spent years meticulously planning and constructing this spacecraft to ensure it can survive the harsh conditions of space. The Parker Solar Probe has to withstand extreme temperatures and intense radiation. As it ventures closer to the Sun than any spacecraft before it, the probe faces challenges that push the boundaries of current technology. The spacecraft is equipped with a special heat shield to protect it from the Sun's heat. This heat shield, known as the thermal protection system, is a critical component that ensures the probe's survival. This heat shield is made of a carbon composite material and is 4.5 inches thick. The material is designed to withstand the intense heat and protect the instruments on board. It can withstand temperatures up to 1,370 degrees Celsius or 2,500 degrees Fahrenheit. This incredible capability allows the probe to get closer to the Sun than ever before. The probe's instruments are also designed to operate in the harsh environment near the Sun. These instruments are crucial for collecting data that will help scientists understand the Sun's behavior and its impact on the solar system. They are shielded from radiation and can withstand the extreme temperatures. The combination of the heat shield and radiation protection ensures that the instruments can function properly and send valuable data back to Earth. The Parker Solar Probe's mission profile is carefully planned to minimize its exposure to the Sun's heat. The mission team has devised a trajectory that allows the probe to gather data while avoiding the most dangerous conditions. It flies in a highly elliptical orbit, making close approaches to the Sun before swinging back out to a safer distance. This orbit allows the probe to study the Sun up close while ensuring it can cool down and transmit data back to Earth during its retreat. Space weather, much like terrestrial weather, affects our daily lives in surprising ways. From satellite communications to power grids, the influence of solar activity is pervasive. Understanding space weather involves studying solar flares, coronal mass ejections, and their impacts on Earth's magnetosphere. Scientists are continually advancing their methods to predict space weather, aiming to mitigate its effects on our technology-dependent world. As we look to the future, the quest to understand our Sun and its effects on space weather continues. Upcoming missions are set to delve deeper into the mysteries of our star. With advancements in technology and international collaboration, we stand on the brink of discoveries that could revolutionize our understanding of the Sun and its relationship with Earth. The future of solar science is bright, and the journey has only just begun. We are entering a new era of solar science. With cutting-edge instruments and innovative missions, researchers are uncovering the Sun's secrets at an unprecedented pace. This new era promises to enhance our ability to predict space weather events, protect our technological infrastructure, and deepen our comprehension of the universe. It's an exciting time for scientists and space enthusiasts alike. Thank you for joining us on this journey through the wonders of our sun and the dynamic space weather it creates. As we continue to explore and learn, we gain not only knowledge, but also a greater appreciation for the intricate dance between our planet and its closest star. Stay curious and keep looking up.